Hi, my name is David Stringham, and today I'm going to walk through a recent project for the film Other Halves. For this shot, my brief was to roto the actress and replace the two monitor screens. The first thing that I did was to load the footage into Mocha. And if I turn on the visibility for these layers, you can see all the shapes that I created for the tracking. After that, I needed to create more shapes to use for roto and tell Mocha to use the tracking data from those layers. This enabled me to create accurate mattes with a minimum number of keyframes and ensured a higher level of accuracy than I could get otherwise. I also tracked the screens and other obscuring objects to account for any camera movement that might be present. Now I can play back the shot, and you can see how the shapes animate to follow the face and body. The next thing to do was to export each shot to Fusion. So if I have one of these layers selected, I can go to Export Shape Data, and Mocha makes this easy using the Apple Shake SSF format. And then I just save out each shape individually. So, one moment here. So now in Fusion, I need to create a group of polygon tools. Polygon here. And import each roto shape. Going to polygon, import SSF shapes. And then I just find that folder where I save them to. Got one here, and bring that in. Okay, so now I have the shape. And I just copy paste them into my main comp right here. And I just paste that in. The reason I bring them create them in a different composition and copy and paste them into my main one is that this often causes Fusion to crash. So create a few polygons, copy them in, and then save a lot. Anyway, I have them organized into these two groups. So you can see all the polygons that I've created for both the actress's head and her shirt. And so the reason that I do it this way is that creating a whole bunch of polygon tools in the main comp and importing the SSF shapes often causes Fusion to crash. So I set them up in a different composition, copy them in, and then save. A lot. Anyway, I have my roto organized into these two groups. So we can see the tools by clicking on the windowed buttons on the groups. So you can see all of the shapes that I've created, both for her head and for her shirt. If we, now I'm going to select one of the shapes and look at the properties for it. Specifically, I'm going to click on the motion blur tab, and not on this one, but if we go to like her head or neck. Yes, okay, so for some reason I had motion blur on that shape, but yeah, okay, so for this one, motion blur is turned on, and I'll load this into the viewer so we can try to see it. And you can see a little bit of this blur going on, particularly around her her nose, and this area here is something that I'm going to have to fix again. I don't know why that's happening, but yeah, there's a little bit of motion blur here. See if I can find a little better frame. Yeah, you can see this soft edge where her nose is moving. Okay, I'll minimize these, and we can look at the blur tools. I decided to use these instead of soft edge because they allow me to blur the entire output of a group at once. So I won't have to go into each polygon tool and adjust the soft edge individually. So the two branches then get merged together and plugged into the mask output of this background tool. Yep. I originally omitted this and ran into problems because I needed the mask to be converted to regular RGBA image format. This allows me to use masks like any images. But I still ran into some problems later on, as you'll see. Okay. And then combined the mask for our actress with an ultra keyer. To get some of the hair detail right here. Fortunately, the hair was so blown out that neither roto nor keyer could do much. I then used the merge mat to cut out the actress and make the background transparent. Right here. Yep. Okay. I also use one color corrector tool to remove the green spill generally, and another color corrector that just affects the back of the neck in this area. Yeah. Even when using mainly roto to isolate the foreground element, spill suppression is still required, especially with an illuminated background like we have here. Yeah. So the next step is to add the CG screens. Moving over to the underlay that says screens, you can see that I have these two loader tools. These load in the images for two computer monitors. So let's look at those. Yeah. So these images. I'll have to check to see if there's supposed to be two different screens, I think, but anyway. So these loaders then feed into color gain tools to make the screens appear a little brighter. So you can see, got that. Now, as we get to the two tracks that I imported from Mocha, under Operation, I've set the operation to corner positioning. Merge is set to FG over BG, or foreground over background. And I had this background tool right here piped into the background input for both of the trackers. Then this merge tool merges both of those together. These two polygons here mask the cup and seat where they occlude the laptop monitor. Now this next group of tools creates a bit of occlusion around the desktop monitor where the edges would overlap the screen. This gets merged with our screens. Actually, zoom in a bit. You can see the difference this makes. And then gets fed into the chromatic aberration tools. The channel booleans, oops, actually I need to fix these here because I got them bypassed right now. So put these into the channel booleans and then onto the grain. Oop. Not like that. Yeah, right there. Okay. These split the input into separate RGB channels. Come on. Which are then distorted by the lens distort tools and recombined at the end. This gives a subtle separation between the colors, like photographing the screens with a real lens. So let's try to see this. If I zoom in a bit more, you can kind of see the shift in the colors. Anyway, next I need to match the noise in the original plate. Unfortunately, Fusion does not have an automated tool for doing this, so it must be done completely by eye. The best way that I've found to do this is to add a blur tool, and find my blur tool. There we go. To remove the grain, and in ellipse mask, so there's my ellipse, as well as a grain tool. Okay, got the 3 nodes, and so now connect the footage to the blur, and then the blur into the grain, like so. Now take the ellipse and put that into the mask of both tools. See what that looks like. Okay. All that's needed now is to move the mask to where you want to mask the grain and blur, and visually compare each channel while adjusting the grain settings. So I can put it somewhere like there. Go in a bit, turn down the level, and then I would just go channel by channel. Get into my, make sure I'm in my grain tool, and now I turn that down, and just kind of match between the blurred grain footage and the and the original plate. Yeah. Alright, so if I want a little more grain in the blue channel, something like that. And then we could adjust the grain size and maybe yeah, just the grain softness and maybe the grain size. And then we just delete these other nodes that we don't need. And now we have the grain that we can use to add grain to our screen replacements. Now the actress gets comped on top of the screens. Go back to color. Yep. And this polygon just masks some of the hair that's still causing a problem. Yes, right here. And finally, the screens with the actress get comped onto the plate. We're almost done, but there are a couple of things left that can be done to integrate the screens better. Going back to the top of the flow, you can see these light wrap tools. What I've done here is taken the rotomat, blurred it, inverted it with a bitmap tool, and use it as the foreground input in a matte control tool. The unmodified matte then goes into the background input. I have it set to combine the red channels, which was just a personal decision. Also, I checked the post multiply image setting, which multiplies the mattes and gives me an outline just inside the actress. I used a matte control tool due to some of the channel limitations in Fusion, as I mentioned before. My first attempt involved a merge node set to multiply, but Fusion treats mask outputs as different from standard RGB images, and this may be because I had this bitmap tool, which is a mask, but I just could not find any other method that worked. The matte control is set up to work with mask outputs and is therefore the only method that I found to work. Coming down, I had this tracked polygon mask that removes the light wrap along the top where I don't want it. So there. This then goes into a merge tool where it is combined or multiplied with a blurred version of the composited footage. So there's the multiply. The output of this merge then gets screened over the footage with the blend amount turned down for a more natural look. Also, this light wrap mask group removes the light wrap on her body here. So here's before and after applying the effect. Okay, the final thing to look at is edge blending. Going to the top again, I've split the matte output as before, but this time I have blurred both branches. These blurs have slightly different blur sizes so that when they're merged with the XOR blending mode, I get this soft outline. The size of the blur amounts is up to the compositor, but it should always be a subtle effect. Following this pipe down, I have plugged it into a bitmap tool. Just as with the light wrap, I only want there to be edge blending with where her body overlaps the screen. And now the output of the bitmap goes into the mask input of a blur tool, and the output of the light wrap merge goes into the blur input. And now the edges of the actress are blended with the screen. I'll zoom in a little bit more so you can see this. Light wrap, and then the edge blending. Okay. Then the blur plugs into Saver, and that finishes this screen replacement. Hope you enjoyed this little breakdown, and you are welcome to watch more of my videos. Liking and subscribing is, as always, appreciated. Bye for now.